This is the 3-3 to 3-5 review. Again, we do get calculators for this, and you will actually need them. So, number 9 says, consider the pairs of functions below at what value of x do the graphs of f and g have parallel tangent lines. Well, we all remember that parallel means the slopes are the same, and in this class, slope is the same as derivative. So what we're really looking for is for when the derivative of f is the same as the derivative of g. We need to set those equal to each other and then use our calculators to solve for when that occurs. So let's look at the derivative of f on part A. Derivative of f, move through the 2, hit the e, it stays the same, then hit the power, and we end up with 6e to the 3x. Derivative of g, we move through the constant, we hit the power, simplify, you get 21x squared. So now I need those two slopes to equal each other. So I'm going to solve for when 6e to the 3x equals 21 times an x squared. So on this one, I'm actually going to do it on my graph so that you get to see exposure to how the graphs work. So I'm going to go into y equals, and I'll put 6e to the 3x in for y1, and I'll put 21x squared in for y2. Now I need to graph both of these functions and see when they intersect. So I'll just do a zoom 6 and look to see if there's a picture that actually intersects. So there was my exponential. Here comes my quadratic, and we can see, even though it's a little tight, we can kind of see that there's an intersection right here. We have that exponential heading up, and we have the quadratic coming down, so probably right through here. So to find the intersection, I'm going to go to my math menu, just like I have on my TI-84s. It's under calculate menu, so same place. So that's F5, and we can see that we can look for an intersection on number 5. So I'll go down to the intersection. Now, just like on your 84s, it's going to ask what curves do you want to have intersect. Since I only have 2 curves graphed, it'll be blinking on my y1, so I can hit enter. Then it'll blink on y2. Those are the 2 that I want to intersect, so I hit enter again. Now, what's a little different is that on the 84, it will ask for the guess, and here it just asks for the lower bound. So lower bound means we need an x value that is less, that means further to the left, than the intersection. So I move past that intersection using my arrow buttons. There I'm to the left, I can hit enter, and then it asks for an upper bound. So that's someplace on the right of the intersection. So I move to the right of it and hit enter, and then it will find it for me. So my intersection was x equals negative 0.327. So I have found the x coordinate for which the equation here and the equation here will have parallel tangent lines. So let's look at part B. Same scenario. We need f prime, which is e to the x squared. I hit the e, stays the same. Hit the x squared, I get a 2x. I need g prime, which is just a simple power rule. And then I need to set them equal to each other. So I will be solving for when 2x e to the x squared equals negative 3x squared. So again, I'm going to go to my calculator, and I will see if I can scoot this up here and see it all. I'll go to my y equals, clear out what's in there, and I'm going to put in y1 my 2x times e to the x squared. Then I need that. Hit enter. Then I need the negative 3x squared in y2. Then I'll do zoom 6 to see if I can see an intersection. Here is my exponential term. Here's my quadratic term coming. And we can see that there's an intersection. So we have a decent window. So to find that intersection, again, we do the F5 math menu. So I hit F5. I want the intersection, which is number 5. first curve, hit enter, second curve, hit enter. Lower bound means I need to be to the left. Upper bound means I need to be to the right. Hit enter, wait, and it finds that intersection at x equals 0. If we look at part C, again we have the same scenario. We need f prime, which involves e unchanged times the derivative of the power. So we end up with 3e to the 3x plus 2. And if we look at G, I have rewritten it as negative 7 times x to the negative 1 so that we can take its derivative really simply. That'll give us a 7x to the negative 2, or a 7 over x squared. So again, since we want them to have parallel tangent lines, we're looking for when 3e to the 3x plus 2 equals a 7 over an x squared. So just like before, I am going to go to my calculator and graph these and see if we can find the intersection graphically. So this method will work for both the 84s and the 89s, and I just want you having practice doing with them both. So I've entered in y1 is 3e to the 3x plus 2, and y2 is 7 over x squared. So if I do a zoom 6 at first glance, and I wait to see what happens, there's my exponential, and here comes my rational function. Maybe, here we go. So this one here was the 7 over x squared, and this one was my exponential. And if we look at it right now, it's kind of hard to see whether or not there's a solution or not, whether they intersect. Over here I've got this 1 over x squared, and then I've got this exponential. Chances are good that exponential is going to be getting closer to the 0 faster than the rational. So there's probably not going to be a solution over on this side. But if we think about the exponential, we know that this exponential is an e to the 3x plus 2. So that means it's going to grow on the right, and eventually it's going to cross this x-axis, or excuse me, this y-axis. So we know it's got to end up way, way off the screen up here. So that means that my window is not showing me what I need to see. There's probably going to be some sort of an intersection between this exponential and this rational, but it's up here somewhere. So in order to adjust my screen so that I can see it, I'm going to think about what I think the intersection should probably be. It's probably not going to happen on the left side. It's going to happen at some point after this crosses the x, or crosses the y-axis. So I'm going to look just from, say, -2 to +2, and we'll see what happens then. And maybe I'll go up higher. Right now I'm only going up to +10, so let's go up to a +100, let's say. So I'm going to adjust my window by doing diamond F2, and I just want to look from -2 to 2. And for my y's, let's go up to 100, and then we'll graph. So diamond F3, and we'll see if we can see an intersection. Here comes that exponential. It's behaving the way we think. It's growing on the right. And here's our rational. Oh, look, now we can see that intersection. So to find the intersection, we'll do F5. 5, first curve, second curve. We need to be on the left, which is the lower bound, and I already seem to be there. So we'll just hit enter, and then we need to be on the right. Now I'm on the right, so we can hit enter, and we see an intersection at 0.38, or excuse me, 0.338.